No system can sustain a situation such that there is an unbalanced force anywhere inside the system, or there is a difference of temperature anywhere inside the system, or there is a difference of composition anywhere inside the system. The system will always try to reach such situation where there is no unbalanced force inside the system, or there is no difference of temperature, or there is no difference of composition inside the system. Such a state of the system where there is no unbalanced force, no difference of temperature, or no difference of composition inside the system is called equilibrium. Then we say that the system is in equilibrium. So the equilibrium can be of three different types mainly. Number one, mechanical equilibrium, that is nowhere inside the system there is any unbalanced force exist, that is the mechanical equilibrium. Number two is thermal equilibrium. It is a situation where there is no difference of temperature anywhere inside the system. Third one is the chemical equilibrium or compositional equilibrium, where the concentration or chemical composition of anywhere of the system is same. When inside a system all these three, that is mechanical equilibrium, chemical equilibrium and thermal equilibrium exist, then we say the system is in equilibrium or thermodynamic equilibrium. Next is the concept of process. When by any means any of the condition of thermodynamic equilibrium is disturbed, then the system will again try to come back to its equilibrium state or a new equilibrium state. That is, then a process will start. That is how, by disturbing the equilibrium of a system, a process can be started. Now, a process can happen various ways, like it can happen very fast, it can happen very slow, or it can happen under a constant pressure at a constant temperature, or it can happen at constant volume. Depending on these conditions, the various process can be defined. If a process happens at constant temperature, then we say it is a isothermal process. If it happens at constant pressure, then we say it is a isobaric process. If it happens at constant volume, then we call it isochoric process. If during the process the system neither exchange heat or mass with the surrounding, then we say it is an adiabatic process. If after the process the system come back to its initial state, then we called it is a cyclic process. A system can be made to undergo a process in such a slow manner that at every step the changes associated with the process will be same in magnitude but opposite in sign if the same step is gone into backward direction. Then that kind of process is called reversible process. Next is the concept of state variable or state function. There is another aspect of classifying thermodynamic properties or thermodynamic variables. For most of the thermodynamic properties or variables, a value can be assigned with respect to state of a system or for a state of a system. Those kind of properties are called state property or state variables. There are also a few thermodynamic properties with respect to which we cannot assign any value for the state of the system. So those kind of properties are called non-state variable or non-state function, or sometimes they are also called path variable. They does not depend on the state of the system. Rather, they depend on the path of the change of state of a system.